Welcome to a lesson with Dr. Powell. Let's talk about how we can find the center of mass, but in the case when mass is evenly distributed. So it's really like a center of area. So with even distribution of mass, then we would really be looking for a geometric centroid, kind of center of area type thing. So let's start with this particular situation where we have a parabola, y equals x squared. And we'll go from 1 up to 2, and we'll look at this region. We'll look at this region in here, right in here. Where is the center of area or mass here? So this will be a coordinate, an x bar, which we'll label x bar, y bar. So some coordinate in space here. Let's erase the inside here just so we can kind of notate some things as we go. So basically what we're going to do is we're going to find kind of an average x value and an average y value with respect to, let's think about area as mass, if you will. So with respect to mass, changing mass. So what we need is we need kind of a mass variable. We'll call this m. Now what m is going to be, it's the amount of area, or the amount of, which is, we'll say is mass here, the amount of area that you have up until a certain point as you go this way. So at the beginning of 0, maybe up to here, you have this much area, then that much. So m will just be the area up to a point. Now notice that that if I give you a certain amount of area or a certain amount of mass, so if I give you a certain amount of mass, then I can tell you exactly what the x value is that refers to that particular mass. In other words, x, not only is mass as a function of x position, but x's position is actually a function of mass. It goes both ways. So you could have x as being a function of m. We're not going to worry about what the formula for that is, but at least we can think about it as x being a function of m. So to find the average x value, actually, we find the average of this function with respect to m. Now, to find the average value of a function, you simply take 1 over your total length of interval. So m is traveling from 0 up until the total area here. So total area minus 0. So from 0 to a, so as mass goes from that, we're going to be looking at the average value of this function. So we integrate this function, divide by the length of the interval with respect to m, and that will tell us precisely what x bar is, which is the coordinate of the centroid. So this is great. But what we're going to do now is we're going to make this something we can integrate. So we'll change our variable. dm, let's express dm in terms of dx. It'd be nice if we can visualize what dm is. Okay. And how it relates to dx. Well, so for a little, if x changes a little bit, dm will change by a little bit, like this little guy right here, like a little sliver. So a little change in x, a little change in x, a little dx change will induce kind of this much change of dm. And roughly speaking, as things get smaller and smaller, this is actually very well approximated by a rectangle. So we can think about a rectangle for the relationship between dx and dm. Dx times the height here will be equal to dm. So dm will simply be dx times the height of this, which is simply the function, the y value right here, so x squared. So dm is simply going to be, in this particular case, will just be x squared dx. And then we just have x, which is just x now, because we're switching to dx, and that's a a chunk here, which refers to x. And so we basically have this. Now the interval, as m goes from 0 to a, x is going from 1 to 2. Total area we could get by doing a little integral of this, x squared, as we go from 1 up to 2 dx. We could compute that to be, let's see, x cubed over 3 from 1 to 2. So that would be 8/3 minus a third, which would be 7/3. So we just take, okay, so that's total area. So we're just taking the reciprocal of that, 3/7. So this right here will be x bar. X bar will be equal to that. That's the setup. And we could go through and make that computation now. Okay. So this is just x cubed. So we're going to get x to the 4th over 4 from 1 to 2. So, and we're going to be multiplying that by 3 over 7. So that's going to be, so that's going to be 16/4, which is 4 minus a 4th. So 4, so it'd be 4 minus a 4th, which would be 15/16. Let's see. Okay, yeah, sorry. So 4 minus a 4th, which would be 15/4 is what I meant to say. So 15/4 times 3/7. So we're going to get 45 over 28. So x bar will be 45 over 28. Okay. Now, how do we find y bar? So to find y bar, we could just kind of turn the table around and kind of go and think of the shape and kind of going up this way with the mass variable. But we can keep with the same dx and dm relationship here. If we think about finding the average value of the middle y value here. So the middle of, so here at this particular m value or x value, what's the middle y value? It's the y value right in between here in this shape. So right between 0 and the function. So it's like the average of the function and the bottom function, which in this case is really simple. You're just dividing it by 2. So x squared over 2 is kind of, or is equal to y over 2, and that's what we're finding the average value of. So really we have the exact same setup, and we just go for it. So in this particular case, to find y bar, again, we have 3 over 7 because it's over the same interval. Again, we're going from 1 to 2 because we're integrating with respect to x. But instead of putting x down, we simply put x squared over 2, but everything else is the same. Same dm, just a different function that we're finding the average value of with respect to the mass variable. And this right here is your differential dm. So then we can compute this. So let's compute y bar. So this is x to the 4th, so integrated to x to the 5th over 5 to 2. I'll put out there. So we have 3 over 14 times, okay, whatever, times that, and then we go from 1 to 2, and so that would be 30. So that would be 32/5 minus 1/5, so 31/5. So that's equal to 3 times 31 over 5 times 14, which is 70. So we get 93 over 70. Okay, so y bar would be equal to 93 over 70. And so we were able to compute the centroid using this basic idea of average value with respect to this mass variable. Thanks for watching.